This time, like, and in this video we are looking at partial fractions. So the best way to look at partial fractions is just to do a few examples, and we have lots of different types of examples which will require slightly different methods. Now the first one is the easy example, and this says that x plus 8 over x minus 4 and x plus 2. And to start this off, we have to split the fraction up. So we're going to say that this is equal to a over x minus 4 and then this is adding b over x plus 2. So what we've just done there is simply split it up. And then what we're going to do is multiply everything by the denominator. So the denominator here is x minus 4 and x plus 2. So if we times everything by x minus 4 and x plus 2, then what we end up with is x plus 8, because we've cancelled the denominator on the left hand side. And then that is equal to a and then x plus 2. Because the x minus 4 has cancelled, but then we still got an x plus 2 because we're times it by both. And then that means that b is multiplied by x minus 4 there. Now the next step is we have to cancel either a or b to find the other one. So we're going to cancel a first of all, and we're going to therefore let x equal minus 2. Now x is equal to minus 2 because if we do minus 2 plus 2 we get 0, which means that a is going to cancel. So then we just got to sub it in. So minus 2 plus 8 is equal to 6. And then minus 2 minus 4 here is going to be equal to minus 6b. Therefore b is equal to minus 1. Now we need to work out the other one, so this time we're going to let x equal 4. And that is because 4 minus 4 is going to be equal to 0, and we're looking at here, and that means that b is going to be cancelled. So if we let x equal 4, then we have 12, so 4 plus 8, that's 12, is equal to 4 plus 2, and that's 6a. So therefore, a is equal to 2. So we've basically finished here. All we have to do now is sub these in. So then we have 2 over x minus 4. And we're just subbing them into our first thing round here. That's what we're subbing them into. Just putting a and b into it. So then a, and then we're going to do minus 1 over x plus 2. And that is our final answer once we split it all up. So the next question includes something squared in the denominator. So this one says 2x squared plus 11x plus 19 over x minus 1 times by x plus 3 squared. And this does have a slightly different method, as when we split it up, we're going to split it up into 3 parts. Now the first part is just going to be a over x minus 1. That's normal. The second part though is going to be b over x plus 3. And then the third part is going to be c over x plus 3 squared. Now, once again, what we're going to do, I'm just going to put brackets around this just to show that it's all squared. But once again, what we're going to do is times it all by the denominator. So this time we get 2x squared plus 11x plus 19. And then this is equal to a number of things. So we have a, and that is times by x plus 3 squared. And then we've got b. Now b is going to be the one which is times by 2, so we're going to have x minus 1 and x plus 3. That's a one which is slightly difficult to cancel, but I'll show you how to do that later. And then finally c is going to be by x minus 1. So we'll start off by cancelling the a, so therefore we're going to let x equal minus 3. Now if you put minus 3 into 2x squared plus 11x plus 19, that means that we're going to get 4. And then that is going to be equal to, so the a is going to cancel, the b is also going to cancel because you have minus 3 plus 3, which is going to be 0, so it's 0 times by something, and then c is going to be minus 4c. So therefore c is equal to minus 1. Then we're going to let x equal 1, and this is so that we can get what a is. So when x is equal to 1, then what we get is a is then 4 squared, which is equal to 16a for this one. And then if we put it into the 2x squared plus 11x plus 19, we're going to get 32. Again, b is going to cancel because we've got a 0 here. But then that means that a is equal to 2. So in order to get b now, which is the final step in the one what we didn't have to do in the first thing, we're going to let x equal 0. And by doing this, nothing's going to cancel specifically. However, what will happen is, because we've already got a and c, which is why we have to work them out first, we don't have to put them in terms of a, and we will have proper numbers. So if we put 0 into this, then we're simply going to get 19 is equal to, and then we've got 9, so 3 squared a, so we got 9a, which is equal to 18, because 9 times by 2 is equal to 18. Then we get, if you put 0 into here, then we get 0 minus 1, so minus 1, and then 3, so we get minus 3b. And then we get minus 1c. c is minus 1, so that means that minus 1 times minus 1 is equal to 1 plus 1. So you may be able to see that what we've got here is going to cancel. So the 18 will cancel, the 1 will cancel, and then 19 here will cancel. But 18 plus 1 is 19. That's going to cancel. So therefore we know that minus 3b is equal to 0. So therefore b is simply equal to 0. So in fact, we didn't necessarily have to worry about it for this one, but you always got to do these steps because often b will be equal to a number and you will have to put it into your final answer. But because b is equal to 0, therefore our final answer will be 2 over x plus minus 1 plus, or minus in fact, and we will just put a minus sign there, minus 1 over x plus 3 squared. So the next question again has another dimension to it, and when the numerator has a higher or equal power than the denominator, an extra number must be added, or an extra letter as well, you could say. But this one example shows that when the power number is equal to the denominator, and this means that a is added. And you can see that this has x squared, and this also would have x squared if we expand the brackets. So therefore we have a plus b over x minus 2, x plus 2, sorry, plus c over 3x minus 1. and that is what we're going to put it into. So first of all, we will again follow exactly the same steps, and we're going to multiply it all by the denominator. So again, it always starts off with this same step. And that means that 9x squared plus 20x minus 10 is going to be equal to a. And then because a has no x, nothing's going to cancel from it, so we're just going to have a and then x plus 2 and 3x minus 1. And then b is going to, the x plus 2's are going to cancel, so we're going to get b and then 3x minus 1. And then finally plus c, and then that's going to be x plus 2, because the 3x minus 1 is going to cancel. Again, following the same steps, we're going to try and cancel either this b or this c. The c looks easier to cancel, so we'll start with that first, and then we're going to let x equal minus 2. You let x equal minus 2, you put it into this, you will end up getting minus 14. Then the a will cancel because we've got a 0 there. The b won't, however, cancel, so therefore we're going to get minus, that's minus 14. So therefore we're going to get minus 7b. So therefore b is equal to 2. Now the b here looks slightly harder to cancel, as we've got a 3x minus 1. All we're going to have to do is let x equal a third, and then we may have to use a calculator a little bit to work this out. Let x equals a third. This means that this will go to minus 7 over 3, and then this again will cancel. This will cancel, but then the c will be 7 over 3c. Which means that c is going to be equal to minus 1. So finally, in order to get what this a is, we're going to have to use the tactic of putting in a 0. So when x is equal to 0, therefore we're going to get minus 10 is equal to this. So then 0 plus 2 is 2, and then 0 minus 1 is minus 1, so then that's going to be minus 2a. And then, so then for b, we're going to put 0 in here, so we got 3 times 0 is equal to 0, so minus 1. So that's minus 1b, and then b is 2, so that's going to be minus 2. And then for c, we've got 0 plus 2, so that's 2, and then we're going to put 2 minus 1 again, so that's another minus 2. And therefore, if we start rearranging this, we'll have plus 2, so plus 4, so that's going to be minus 6 is equal to minus 2a. So therefore, a is equal to 3. So that's going to leave us, therefore, with the final answer of 3, because that's a, plus 2 over x plus 2 plus, or minus, in fact, minus 1 over 3x minus 1. And that is our final answer for an example like this. So the final question just has one more dimension in, and this is when the power number is higher than the denominator, and in this case ax plus b is added. So here we have a question: 2x cubed plus 7x squared plus 8x plus 2 over x plus 1 times by x plus 2. And obviously we have an x cubed on the numerator, but we only have an x squared on the denominator. So this means that we're going to add ax plus b, and it's going to go to plus c over x plus 1, and then plus d over x plus 2. But again, it's the same steps, and we're going to first of all times by the denominator. And timesing by the denominator, we'll get 2x cubed plus 7x squared plus 8x and then plus 2. And then ax, again, here nothing is going to cancel, so we're going to get a x, and then we're going to get x plus 1 and then x plus 2. For the b, we're going to get the same thing, as nothing will cancel. So b, we get x plus 1 and x plus 2. So for c, this is when we start cancelling, and we're looking at what we were looking at in the first question now, and that's going to be x plus 2. And then for d, we'll get d and then x plus 1. So obviously this is looking a lot more long-winded, but we're still going to have a similar process here. And we're going to start off by letting x equal minus 2 to get rid of that c, which will simultaneously get rid of the a and the b. And by letting x equal minus 2, we're going to get this is going to be equal to minus 2. And then here, that gets rid of there, this gets rid of, and then we get minus 2 plus 1 is going to be equal minus 1d, so that's equal to minus d. So therefore d is equal to 2. So next thing to do is to be looking at getting this c here and cancelling this. So therefore x is going to be equal to minus 1 this time. And if you put minus 1 in here, then we're going to get minus 1, just comes out as that. And then this will be equal to the minus 1 plus 2, so that's equal to c. So again, nothing is needed there to rearrange. C is equal to minus 1. So this time we're going to let x equal 0 again, and this is in order to get the b, because by letting x equal 0, everything else will cancel, including the ax, because there is an x there. So we let x equal 0, then we're going to get 2 is equal to, and then this will cancel here, but this is going to be 0 plus 1, 0 plus 2, so that's 2b. And then this is 2c, but that's going to be minus 2 because c is minus 1. This is going to be equal to d, and d is equal to 2, so plus 2. But that means that b is simply equal to 1. And then finally, in order to get a, we're just going to put in a random number which doesn't cancel anything else. So, for example, we could use here x is equal to 2. Obviously, the lower number you use, the easier it will be. If you use a high number, you're obviously going to be using much larger numbers. But if you put x is equal to 2, then we have 62 there. That's equal to 24a because we have putting x equals to 2 there, we have 24a, and obviously we don't know what a is, that's the thing we're trying to find out. So if we put 2 into here, then we're going to have 2 plus 1, and then 2 plus 2, so that's going to be 3 times 4, which is equal to 12, so that's plus 12b, and that's obviously just going to be plus 12. Put it into here, then we're going to get 4c, c is equal to 2 things, so that's going to be minus 4. And then put it into here, we've got 3d, d is equal to 2, so that's going to be plus 6. Rearrange all of that, and then what we're going to get is 48 is equal to 24a, which means that a is equal to 2. So therefore, finally, after doing all that work, we can now have a final answer of 2x, and then b is going to be plus 1, and then plus, we'll put in the d first because that's positive, so then we've got the 2 over x plus 2. And then finally we have the c, and that's negative, so we got minus 1 over x plus 1. And that is our final answer. So thank you for watching this video, and see you soon. Bye.